Let's talk about using Microsoft Excel to calculate a confidence interval. And for those of you that watched the video example before this, which was doing a confidence interval for P by hand, I thought for this one that I would grab us some current data. So you saw in that one a poll concerning death penalty with some 2008 data. I grabbed us an October 2014 Gallup poll, which showed that 63% of voters nationwide favored the death penalty for persons convicted of murder. For your information, a typical Gallup poll is composed of a randomly selected sample of 1,000 voting adults. We'd like to obtain a 90% confidence interval for the proportion of registered voters nationwide who are in favor of the death penalty for persons convicted of murder. So interestingly enough, if you watch that video, the 2008 data actually showed a sample proportion of 0.63, same as our 2014 data. In fact, all the way back to 1976, the Gallup poll's estimate of percentage of voters in favor of the death penalty has been 60% or higher. It was 1972, I think, was the last data value that was lower than 60%. Just some interesting information for you. I've included the link to that particular data if you'd like to check it out. All right, so our next question is, are the conditions for the binomial distribution, in particular, right, are the conditions for the normal approximation to the binomial distribution satisfied? Right, so if we were to look, all right, first we check, right, n times p hat, and we can see that that's 630, which is clearly greater than or equal to 5, and then we check n times q hat. Remember, q hat is just 1 minus p hat, right? So that's clearly also greater than or equal to 5, right? And the one thing we also want to note is that alpha is equal to 0.10, right? We're doing a 90% confidence interval. So alpha over 2 is 0.05, and z alpha over 2 then is 1.645. Remember, that's the z value that's bounding the top 5% of the normal distribution. All right, so if we jump into Excel to calculate our values, we want to note a few things, okay? So first, let's note p hat. P hat was 0.63, right? And our sample size was Gallup poll, typically 1,000 people, right? Alpha was 0.10, right? Which made z alpha over 2 1.645. All those things are important in calculating our margin of error, right? Which I've given you the formula for right here. So I'm going to give myself a little label here. E is equal to, okay, so I'm going to calculate my margin of error. So all I say is equals, right, and then I start calculating. So I want to do, right, z alpha over 2, don't type these values in again, just click the cells that have their values, right? Z alpha over 2 times the square root of p hat times 1 minus p hat. So p hat times 1 minus p hat divided by n, right? And then I close up my square root. There you go. There's my margin of error, okay? It's that simple. So my lower bound for the confidence interval consists of, right, it's equal to p hat, right, my estimate for the proportion, minus my margin of error. That's your lower bound, right? So the lower bound for my interval is 60.5%, or 0.605 as a proportion, right? So then my upper bound for the interval is equal to, right, p hat, my estimate for the true proportion, equals my estimate for the true proportion plus my margin of error. There we go. So there's my lower bound, 0.605 to the nearest thousandth, and my upper bound, 0.655 to the nearest thousandth. So we're estimating between 60.5% and 65.5% of voters are in favor of the death penalty. All right, so if we jump back right here, I've filled that in for you in a final solution slide. All right, so that's how we can use Microsoft Excel to real quickly and easily calculate confidence intervals for us. And I'm not going to get into it right now, but if you're careful and you think ahead a little bit, you can set up Excel files that you can reuse to calculate confidence intervals that you can just dump data into and have things kind of set up nicely. But I'll leave that to you if you want to put the time into doing that.